Students, this is the table used for to find the resistance of the given wire using meter bridge. Now what we are going to do that? I switch on the battery and I will fix the resistance value as a 5. In the resistance box, I will fix the value 5 ohm. So what is the resistance value? 5 ohm. So I will write that in the resistance box the given value is 5 ohm. Now take this jockey and keep it on the meter bridge. Okay, keep it on the meter bridge at a particular distance. What will happen? The deflection will become 0. You see that the deflection is there? Yes or no? Yes, it is moving here and there. Are you able to see that? I will show you very closer. So galvanometer reading is moving here and there at a particular distance. What is this? This at a particular distance the galvanometer becomes 0. So if the galvanometer is moving means I am sliding here and there in the meter bridge wire. So you are able to see that I am moving here and there at a particular point the galvanometer shows 0 deflection. So that length is a balancing length. That length is a balancing length. The length is here, it is exactly 53 centimeter. 53 centimeter. What is the balancing remaining? 100 minus 53, what is that? It is 47. Again, what I will do that? Here it is a 5 ohm. Then the 0.5 ohm is increased. 0.5 ohm is increased. So if I fix 5, here it's a 0.5, 5.5 ohm in the known resistance box. Again, slide this jockey here and there. Again, slide this jockey here and there. What is that? So if I move, what is that? The galvanometer shows the deflection. At a particular point, the galvanometer shows 0 deflection. So that is the length. So what is that length? That length is a 50.5. That length is a 50.5. So in the known resistance 5.5, the value is 50.5. Then again increase 0.5. So that means I will bring this 0.1 ohm to 0. Then this will be increased to 6 ohm. So now I will fix 6 ohm in the resistance box. Again the balancing length is calculated. So the balancing length is, what is the balancing length? So I am moving here and there. At a particular point in the meter bridge, it will show 48.5. It is a 48.5. So the answer is 48.5 for 6 ohm resistor. Again for 6.5, what is the resistance? Then that's all. 5, 5.5, 6, 6.5. Even you can use the 7 also. So the 4 reading is enough, sufficient for us. Okay. Even we can take the reading for 5. That is 7.0. Sir, I want to take the reading from 4.5 means, yes, you can take the reading from 4.5, 5, 5.5, 6, 6.5 and that's all. 1, 2, 3, 4, 5. So even you can use the from 5 onwards or even from the 4.5 because the approximate resistance value is 5 ohm. By doing these calculations, we get an answer. What is the answer? That answer is X value, unknown resistance value. Dear students, I do the experiment with starting from 4.5. I do the experiment with 4.5. So I found that the value is for 4.5 it is 56 centimeter is a balancing length. Then for 5 it is a 53.5. Then 5.5 it is a 51. Then it is a 49. And finally for 6.5, 47. If you subtract the 100 minus 56 is a 44. 100 minus 53.5, 46.5. 100 minus 51, 100 minus 51, it is a 49. 100 minus 49, it is a 51, and 100 minus 43, it is 53. So this is the balancing question. Only this length only we are calculated by using the balancing question. This is the resistance we fixed for each and every balancing question. This is a calculated value, just subtracted with the 100. So what is the formula? First reading, it is the x is equal to, so what is the R value? 4.5 into 4.5 into L value is 56 into 10 power minus 2. Because it is in centimeter, you have to convert into meter. Then what is 100 minus L? 100 minus L is 44 into 10 power minus 2. This 10 power minus 2 and this 10 power minus 2 get cancelled. By solving this equation, I get an answer x is equal to 5.7 ohm. So the answer is 5.7. Likewise, we have to put the calculation for all the observed and calculated experimental values. So for the second reading, it is 5.75, then 5.72, then 5.76, then 5.76. If you take the average mean value for this one, the mean value is equal to, this mean value is equal to 5.736 ohm. So this is the known resistance of a given wire. That is, unknown wire resistance is calculated by using meter bridge experiment. So this is a formula. R is a resistance box value, L is a balancing length of the meter bridge. Meter bridge work on the principle of, what is that? Wheatstone bridge. For that, you take a battery eliminator, it is connected to the meter bridge. Then in this gap, unknown resistance in the first gap. In the second gap, we are going to connect the resistance box. This resistance box value can be adjusted by using the knobs. For the each and every known resistance value, we are calculating we are founding what is that? Balancing length by adjusting the jockey. If you adjust this jockey over this wire, what will happen? The galvanometer will moving here and there at a particular point. At the particular point, what will happen? The galvanometer will come to the 0 point. That particular length is called balancing length. That length has to be recorded in the tabular column, and if you do this calculation, we found the resistance of the given wire by using meter bridge. Simple experiment, students. So observe, write the record clearly. Okay, so if you have any clarification, you can message me or call me for writing the record note. All the instructions are very clearly given in the notes. Okay, so submit the record notes on the given deadline. Otherwise, the record note marks will be reduced. For each and every experiment, 10 marks will be given. So if you are not submitted on the given deadline time, your marks will be reduced, because the record note mark is very, very important for your board examination. So kindly complete the record note works then and there. So 1 week time is given to you. So it is not more than half an hour work to complete this record work, writing work. So spend the time with clear and complete your work then and there. Don't keep the one as it is for the long time. So it is a burden for you to complete all the experiments in the last minute. I hope everyone will complete and submit on time. So the second experiment is over.